Okay, so now we're going to do perpendicular bisector theorem. So it's an if and only if. So again, we got to prove it in both directions. So I'm going to prove it in the one direction first. So we're going to say if, right? So what's the one direction? It's if P lies on perpendicular bisector of AB, then P is equidistant from A and B. Okay, so this is the first direction we need to prove it in. What does the picture look like in this case? So in this case, we got that P lies on the perpendicular bisector of AB. So here's AB, here's P. P lies on the perpendicular bisector of AB. So we know that this is a right angle and that AM is congruent to BM. Okay, and we need to show that this length is the same as that length. Okay, that A or PA is congruent to PB. Okay, so let's start with this. So let's see what we got here. Is this that easy? Yeah, I guess so. Okay, AM is congruent to BM. Since M is the midpoint or whatever, L is perpendicular bisector, or since L bisects, we'll just talk about the one property, since L bisects AB. Okay? Then I'm going to say that, let's call this 1 and then this 2 over here. I'm going to say that angle 1 is congruent to angle 2 since they are both right angles. Right angles. And then I'm going to say that PM is congruent to itself by reflexive. Okay, so now I have side. This side is the same as this side. Angle is the same as this angle. So then by side, angle, side, these two triangles are congruent. So by side, angle, side, triangle AMP is congruent to triangle BMP. And then since the triangles are congruent, you can say that all the corresponding parts are congruent, and AP is indeed congruent to BP by CPCTC. And that's more or less one direction. That means since this is congruent to this, right? Or I should write it with 3. This is congruent to this segment is congruent to this segment. That means that P is equidistant from A and B. Now the other direction. So the other direction is the reverse, or yeah, I guess the reverse, the converse. The converse is if P is equidistant from the endpoints from A and B, then you have that P lies on the perpendicular bisector of AB. Okay, now let's prove this. So, okay, so now here we're given this diagram, right? You got AB, and then P is over here, and you know that this is the same as this, right? So we start off with saying, what can we say here? And then what do I got? Oh, yeah, okay. It's easiest if we say every segment has a midpoint. There's other ways to prove this. This is the easiest way, I think. Okay? Every segment has a midpoint. So let M be the midpoint of AB. Okay, so now M is the midpoint, so that means that this is the same as this. And then you can draw PM. PM is congruent to itself by reflexive. So you draw that in, and then you have it congruent to itself. And then you know, I should have said right after the midpoint, I should have said that AM is congruent to BM by definition of midpoint. And then I also have from the given, since, you know, P is equidistant, that's the same thing as saying PA is congruent to PB by given. And then we have that these two triangles are congruent by side, angle, side. By side, side, side. By side, side, side. Triangle AMP is congruent to triangle BMP by side, side, side. I showed that the three sides are the same. Or the three sides are congruent. Which means that this angle 1 is congruent to angle 2 by CPCTC. Right? These two triangles are the same, so that means that this angle is the same as this angle. And then we know that since angle 1 and angle 2 form a line, and angle 1 is congruent to angle 2, this forces that they're both 90 degrees. Okay? Or that this with the algebra, right? What is it? Measure of 1 plus measure of 2 is clearly 180 degrees, right? But measure of 1 is the same thing as the measure of 2. So it's 2 times the measure of 1 is equal to 180. So then the measure of 1 is 90. And then that means, so you could say since angle 1 and angle 2 form a line and angle 1 is congruent to angle 2, angle 1 and angle 2 are both right angles. Of course, are both right angles. And then, since they're both right angles, right, what can we say? What happened here? Oh, this is what happened. Both right angles. Then we can say that PM is both bisecting and perpendicular, right? The symbol perpendicular to AB, and therefore PM, and therefore PM is the perpendicular bisector of AB, and P is, yikes, and P is clearly on this line, and P is clearly on PM, of course, right? And now you're done. All right, let's just go over that last bit again because I just wrote it and just did it. Okay, so now I have that these two angles are right angles, right? So then that means that this line is indeed the perpendicular bisector, and that's the line PM. Why is it the perpendicular bisector? Well, it bisects it, right? It goes through M. M is the midpoint, so it's bisecting AB. The only thing I needed to show was that it's perpendicular, that 1 is the same as 2. Now, or that I needed to show that it's perpendicular, that 1 and 2 are right angles. How do I show they're right angles? Well, I showed that these two triangles are congruent, which means that 1 and 2 are the same angle. 1 and 2 form a line, and they're congruent, means that they're both right angles, okay, through this argument over here, right? Means that they're both right angles. Then I showed that means that the line PM is indeed perpendicular to AB, and it bisects AB, making PM the perpendicular bisector. And of course, P is a point on the line PM. And now you're done.